Hi, I'm Everett. Welcome to the shop. This week I have a project for one of my buddies at work. His father-in-law has an old BSA motorbike, and he's been waiting very patiently for this part because he gave this to me a few months ago to build. Finally getting to it, and even though it's Christmas, it's a little busy right now, but I figured I'd try to get it done for him so his father-in-law at least has it to put his bike back together for the new year. What was really nice is he actually gave me an engineered drawing sitting on my toolbox one morning, and the only downside about this one is it's in metric, so I'm going to have to do conversions to inch measurements because I don't have much for measuring in metric here at the moment. But according to the print here, the outside diameter of this little cover will have to be 63 millimeters. Thankfully, a 2.5 inch piece of aluminum will suffice as far as that. I have about 4/10ths of a millimeter to play with, so I should be able to clean it up. And what I'll do is I'll put a picture of the bike up, so hopefully when we're done this, he can actually get his bike back together. So mostly turning. We're going to wind up using the rotary table a little bit to put the holes in and do the countersinks. Had to get a countersink for that, and yeah. So we'll set it up in the lathe and start doing the turning. Okay, so first step here is we have to face the outer surface. Then we're going to cut the outer journal diameter to the correct external diameter, and then we're going to start working on the center hole. Once we get the center hole bored to size, then we'll start making the relief features for that lip that goes in the middle. And one more pass. So the outside diameter needs to be 63 millimeters, which we calculated out to be 2.480 inches. Now this won't be really exact because of the fact that the outer surface is a little rough. We're about 2.497 there. So we don't have a whole lot we have to play with here. Use the poor man's digital readout. Or cheap guy's digital readout anyway. So that's touching. So we're zeroed. Let's take it in. Okay. 8 thousandths. Gives us 2,483. We'll take one more thousandth. That should be our outside diameter. 2 inches, 481. Within a thousand, that's good. That part's coming off one way or the other, just this way I don't cut myself. I need to make a 21 millimeter hole, which comes out to 827 thousandths. But to start with, we'll center drill. Mark the spot. should be plenty deep enough for the size this is going to be. You may find this a little bit too fast yet. Yeah, that's a little too fast yet. Try 200. Seems to work. It appears to be. I'm going to have to. I may have to regrind this drill a bit. It's not cutting evenly. And I do believe we reached the bottom of our pilot hole. We're going to take 5, see where it goes from there. It's a small boring bar, so we're going to have some flex in it, have to account for. That is 797. Take another 5 and a hair. $8.20. So we're just going to have to tickle this one on the way through. We're going to do a 3/10 cut. Yep, 828. 1/10 of a millimeter is roughly 4 thou. 1/10 of a millimeter is roughly 4 thou, so that's in spec. You're allowed to be plus 0.4, so right on, we hit that one. What we need to do is set up the other dial indicator as well now. Okay, so this little lip we have to cut inside here is 3 millimeters deep and 38 millimeters across, which in inches, 118 deep and 1.496 across. So it's supposed to be 118 deep. Cut in 100 thousandths of an inch. And back out. This leaves us 18 thousandths on the back of the back face to clean it up after. That's 200 thousandths right there from where we, let's double check where we're at. One inch 448. We need 1 inch 496, so we have another 48 thousandths to come off. So if we take 20 on, actually no, I'm going to split the difference. 48, so 24, so that means I'm going to take 12. We'll go into our 100th thou mark. All the way back to the center. And take it up to another 18 thousandths. This is now cleaning up that back surface. Yes, I know it's going to dig a little bit, but we're going to come up to 24. We'll slowly move our way out. There you go, 149.5, 1.496, at least according to the dial calipers, which they're only good to about 1,000th anyway. Take the burr off. The next step is cutting the shoulder, which is 8 millimeters deep, and the inside diameter on that shoulder and journal on the inside of that shoulder will be 44 millimeters. So, double check, make sure I zeroed there. Zeroed on the face, yep, okay. So if we go, we get 20 thou cut, 8 millimeters is 315 thousandths of an inch. One, two, 300 thou. We'll do 300 thou. We'll clean it all up after. Clean up that shoulder. But it will be a while till we get to 44 millimeters. Inch 776. 44 thousandths left to go. 44 thou. So I need a 22 thousandths of an inch cut. There's 10, 20, 2. This should take us out to finished diameter. We're going to go right up against the back face. We're going 300. Maybe go another, well, 18 thousandths, but I think we're going to have to take it in 2 steps. There we go. Okay, that's 118. Unfortunately, the chips keep piling up. Let's take a skim pass on the way out. Clean up that surface. No, that actually doesn't look bad. Well, this thing reads 1,000th high, so 119 thousandths. We're within 1,000th. We're within tolerance. Now that part's done. I don't trust this lathe as far as parting something that size off, so we're going to throw this in the bandsaw. I'll keep my hand clear. There we go. There we go. This backside here is pretty rough and it's not even anywhere near square, but we can clean this up. And what I'm going to do is I'm going to use this shoulder in the back here to mount it, then we can face this front side. The only thing about that is I don't want to wreck this surface here. So we're going to use some pieces of aluminum, or aluminium as the English call it. There. The actual outer lip here needs to be 2.5 millimeters according to the print, and 2.5 millimeters comes out to approximately 98 thousandths of an inch. Definitely see the run out in the surface there from my less than square cut on the bandsaw. Like I've said before in other videos, there's something about watching metal peel that never gets old. We're looking for 98 thousandths thickness, which we're almost exactly 10 thousandths more to go. For this last cut, what I think I'm going to do, just to try to get a better surface finish, we're going to use this high-speed steel tool. We're going 10 thousandths of an inch. I'm hoping a nice slow cut with a high-speed steel tool will yield a little better surface finish. I don't like the fact that swarf is packing up in there. Actually, that came out pretty nice. I like that. 99 thousandths from where I'm reading. Or within 1,000th of an inch. I'm going to call that good. there you have it. Lathe work is done. Here's our little cover piece. All we need to do now is on the front face here. On the front face here, we'll have to drill 3 holes, countersink them, and then this part's done. So what I've done here is I've actually taken and set the rotary table up on the milling machine table. I've set the center line of the quill to the center line of the rotary table itself. I took the dial test indicator, I mounted it on the end of the quill, and adjusted the X and Y axis so that as I turn the quill itself, the needle now does not move on the dial test indicator. So that indicates that, well, okay, I got about 1/4 of a thousandth, but I mean, that's, yeah, maybe 1/4 at the most. So for all intents and purposes, we're concentric. I can now remove this. We're going to take our part and we'll be setting it in under some toe clamps. What I'm going to do is I'm going to set the toe clamps here with some aluminum shim pieces underneath to protect the surface finish. And I'm going to have to bump the piece of work into place, so that as I put the dial test indicator into the bore and spin the table itself, if I unlock the table and take the worm and disengage the worm, I can actually turn this, and as I turn it, if I turn it and the dial test indicator does not move, then that means that this piece of work will then be concentric with the center line of the rotary table. I can then offset by 27 millimeters, which is half of the 54 millimeter center line of the holes. I can then drill and countersink the holes, and this project's done. I'm going to do the bumping and stuff off camera because I don't really want to bore you guys with tapping them back and forth. So I'm going to pause the camera here and I'll bring you back in when we're set. Alright, so now what I've done is I've gotten the piece of work centered on the table itself. I have the worm disengaged from the worm drive, and as you can see, as I turn it, the needle hardly moves. So we are now set on center. So what we need to do now is take this entire table and the y-axis and shift it this way by 1 inch 63 thousandths. That's 27 millimeters. Well, within a couple tenths anyway. So I've already zeroed my sleeve. Loosen that off. I've also got a dial indicator set up here. So we go 100, 200, 9, there's 1 inch, and 63, 1 inch 63 thousandths. So now we have, we're now offset by 1 inch 63 thousandths. Actually, let's try this guy first. If I can get in there, let's engage our worm. Yeah, we'll call that 185, which means I'll have to use 185, 305, and 65. Lock the table. Print calls out for a 4.7 millimeter hole. I just so happen to have a 4.7 millimeter bit. There we go. That should work. We're at 185 degrees. 305 degrees. And can we clear? Yes, we can. Good. So that's the largest tool we need to get through that, between the finger clamps, or toe clamps rather. Yeah, there we go. to move the table all the way to 65. There's 65. One more hole. Just snuck by that toe clamp. Yep, I'll call that good. I might mount it up in the lathe once more just to give it a quick spin on the front to take some of the scratches off. But there you go. Now you take the burrs off the backside here yet too. Finally got it done. Thankfully he had patience for me to be able to wait. It's been a few months now. It seems like I've always had something else on the go. But yeah, it's really nice when somebody actually provides you with a diagram with tolerances and everything on it. So, but yeah, that was this week's project. I'll put in another finished picture of it at the end here. If you like this sort of stuff, please let me know in the comments below. If you have any other suggestions, or if you have something that you'd like me to try doing for you, let me know. Like I say, I've always got projects on the go, but I can always take ideas. But yeah, otherwise, thanks for watching. Thanks for subscribing. I hope you had a Merry Christmas, really good Christmas, and hope you all have a Happy New Year. I'll see you next week, and I guess it also means I'll see you next year. Thanks for watching.